Alright, so in this video we're going to check out lesson 1.4. We're going to look at the two story problems, one on the front, number 3 here, and then after this we'll look at number 6 on the back page. The hardest part about looking at these story problems is writing the equations. After we write the 3 equations, then solving is not a big deal, but it can be a little bit tricky to write the equations. So when I write these equations, I take it a sentence at a time and see what information I can pull from that sentence to write an equation, and then I continue reading. So let's take a look. There is a $2,800 donation for school supplies. The money will be spent on $20 backpacks. Oh, wake up, there we go. $20 backpacks, $25 sweatshirts, and $5 notebooks. Now, from those first two sentences, we can write one equation. We know that 20 times the number of backpacks plus 25 times the number of sweatshirts plus 5 times the number of notebooks will give us the total amount spent. They've got $2,800 that they can spend. So there's our first equation. Now the next sentence says they will purchase 200 items. So however many backpacks, sweatshirts, and notebooks there are individually, there will be 200 of them total when it's all said and done. So backpacks plus sweatshirts plus notebooks would give us 200. So we got 2 out of our 3 equations written. Last sentence, they will buy as many notebooks as backpacks and sweatshirts combined. So that means the number of backpacks plus the number of sweatshirts would give the same, or be the same as the number of notebooks that we have. So we wrote our 3 equations. Now we need to look to solve. Now this is different than the other 3 variable equations that we saw on this page, because one of our equations, instead of being equal to a number like we had in like number 1 and number 2, one of our equations is equal to a variable. And this makes it a lot easier to solve, because what we are allowed to do is we know that n is equal to b plus s. We can take b plus s and plug it in for n for both of our equations, equation 1 and equation 2. Then that will give us 2 equations with only 2 variables, with b and with s. And we are good at solving 2 equations with 2 variables. That's no big deal. So let's take equation 1 and plug b plus s in for n. So we would have 20b plus 25s plus 5 times b plus s equals 2,800. Now let's simplify. So now we have one equation with just 2 variables left. Let's look at equation 2, and let's plug b plus s in for n. So we have b plus s plus b plus s equals 200. Now since it's all addition, these parentheses don't do anything, so we just have 2 b's and 2 s's, and that equals 200. Now we are left with 2 equations. Two equations with 2 variables. Equation will say a and b. Now we need to look to use elimination to get rid of another variable. Now I'm going to get rid of s, because 30s and 2s, if I multiply here by negative 15, then let's write equation 1. We have 25b plus 30s equals 2,800. Now when I distribute this negative 15, I have negative 30b minus 30s equals negative 3,000. I go to add. Negative 5b equals negative 200. The number of backpacks would give me 40. So we found one of our variables, and now just like what we did in number 1 and number 2, we begin to work backwards. We know that backpacks equals 40. We choose our favorite equation with two variables, so either equation A or equation B. I like equation B better because it has smaller numbers. So we've got 2 times B plus 2 times S equals 200. We know that B is 40. S equals 120, S equals 60. So we have two of our variables, we have B and S. Now we go back to our original equations and we choose our favorite. Well, we know that B plus S gives us N. So that means N would equal 100. So now when we write our answer, we don't write it like X, Y, Z, because this is a real-life problem, right? We're not looking at something on the XYZ plane where we're looking for intersections. We're trying to solve this problem. So when we list our answer, I would expect to see that backpacks, there were 40. Then we had sweatshirts. We had 60. And notebooks, we had 100. So this is how we would list our answer right here. Now when we look at number 6, I'll go through the question and I will set up 3 equations, but then I'm going to let you solve, and if you'd like to check your answer with me, then I'll send you the key in a different email. But we'll at least get our equations set up. So if you want to try to set them up on your own, pause the video right now, try to set them up, and then you can hit play once you're ready to check it. But here we go, writing our 3 equations. An amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each long seat. So we don't have all the information quite yet. We'll get it later in the story problem, but I'm going to start writing my equation now that we know 75 times all the seats in section A plus 55 times all the seats in section B plus 30, and for long seats I'm just going to use a capital L. 30 times L will give us the revenue, which we don't know what the revenue is quite yet, so I'm just going to leave it as R and see if they tell us what the revenue is later. There are 3 times as many seats in section B as in section A. Now what would be really easy to do here for our second equation is say, oh, there's 3 times as many seats in section B as in section A. So that means we would have to have 3B equals A. All right, so like I was saying, it would be really easy to write there are 3 times as many seats in section B as in section A, so to write 3B equals A. But remember, we are writing an equation, so we need the two sides to be equal. So if there are 3 times as many seats in section B, in order to get section A up to the same level of seats as section B, we would need to multiply it by 3. So our second equation would be 3A equals B. The revenue from selling all 23,000 seats is $870,000 bucks. So now we found our revenue for equation 1. Also, they said that there are 23,000 seats. So we have seats in A, seats in B, and seats in L, and that's going to be 23,000. So there are our 3 equations, a little bit trickier than the last one with how equation 2 is set up. But those are our 3 equations, and we would look at solving this similar to how we did the last one, where we know that b is equal to 3a. So every time we see b, we are plugging 3a in. Then we would have two equations with two variables. We would need to eliminate a variable and then solve for the one that is left.